Hey, welcome to video 7.3. Here we're going to graph linear inequalities, and we're on page 7 of your green packet. So right here we're going to determine whether our points lie in the solution set to our following inequalities. So basically what we're going to do is for each one, this is x and this is y, we're going to substitute y in for y and x in for x, and then we're going to see if they're true. For example, on this one, instead of y, we're going to put 7. And then I'm just going to rewrite the rest of this. So is greater than, instead of x, I'm putting 2 plus 3. So now I have 7 is greater than 5. 7 is in fact greater than 5. So my answer is yes, this one is in the solution set. Next, I'm putting 1 in for y. 0 plus 3. 1 is not greater than 3. So this one is no. Okay, this one, I have 4 greater than 1 plus 3. 4 is not greater than itself, so this one is also no, it's not in the solution set. Okay, so let's see, that's one way we can take each individual point and plug it into our inequality and then see if it works. Another way, we can talk about more general terms, and we can plot what that inequality looks like on the entire graph, and then we can take a look at each point wherever we need to and see if it fits into that or not. So what we're going to do is this right here, we're going to graph the line that corresponds to that. So y equals x plus 3 instead of y is greater than x plus 3, because this line is going to be the boundary of this right here. So I've got y-intercept of 3, so I'm going to mark that. And then my slope is 1. Since I don't see anything there, it's 1. So I've got 1 over 1 for both my rise and my run. So there are my points. Now, notice this says in dashed form. So right here, when we've got y is greater than, that means that all the points that fall along this line are not actually in the solution set. So for example, right here when I have 1, 4, this falls on the line. If I have 4 equals 1 plus 3, 4 does in fact equal 4. So this is a solution set to the line, but it's not a solution set to the inequality. If I had the inequality sign greater than or equal to, then this would fall on the inequality. It would be in there. So it's kind of like when you're graphing inequalities and you have the open circle or the closed circle. When we're graphing linear inequalities, if we have something that looks like this, we used a dashed or dotted line. And if we have something that looks like this, we use a solid line. The solid line indicates that all the points along those lines are actually in the solution set, and the dashed line shows that it's a boundary, but it's not actually in the solution set. So here we go, we're going to make that line, but we're going to use a dashed line instead of a solid line. So there we go, there's my line. And then this says to plot the 3 points, and we're going to see where they go. So 2, 7 is 2, 7. 1, 2, 3, 4, 5, 6, 7 is up here. This one is in the point, or is in the solution set. This one, 0, 1, is not. And then this one, the 1, 4, is not. So that's why that's dashed. So everything that's up here is going to be in the solution set. So we're going to shade that in. Every point above that boundary line is in the solution set. And then this asks us to choose a 4th point. We could choose a 4th point anywhere we wanted to. I chose negative 5, 3. So 1, 2, 3, 4, 5, 3, that point. And then to prove that it's in that solution set, I would just put it back up into my original inequality. So 3 is greater than negative 5 plus 3. 3 is greater than negative 2. So it is in the solution set. Okay, this one right here, this point can't be drawn on this grid unless we extend it. So if we wanted to know if it was part of the inequality, we would just substitute it back into our original inequality. So y equals x plus 3, we would do 12 is greater than 10 plus 3. 12 is not greater than 13, so no, that one is not in the solution set. Okay, so this one right here, we're going to do pretty much the same thing. We're going to take this and graph it. First, we are going to put it in y equals mx plus b format. So this one right here, they're asking us to use the commutative property to switch these around. So basically, just like 2 plus 3 equals 3 plus 2, we're going to switch those. Plus 3x is greater than or equal to 2. Then we're going to solve for y. So if we have negative 2y plus 3x greater than or equal to 2, we're going to subtract 3x from both sides. So now I have negative 2y greater than or equal to negative 3x plus 2. Then I'm going to divide both sides by negative 2. And you may or may not remember, but when we divide both sides by a negative number with an inequality, we flip around our inequality sign. So now we have 3 halves x minus 1. So that's our inequality. Now we're going to graph it. So y-intercept of negative 1. Slope is 3 divided by 2, so up 3 over 2. And this one, since we have that, it's going to be a solid line. So I can just draw a nice solid line connecting my points. And then notice that it says that y is less than. So that means we're going to shade the part where y is less than that. So I'm looking at my y-axis, and everything below it is where I'm shading everything that includes that on my boundary. Okay. If I wanted to pick a solution that was that works in my original inequality, I can pick anything in this point right here. I picked 3, 0, but you could pick anything that's in that shaded portion. Okay, sometimes we also have a horizontal and a vertical, so let's remind ourselves of those. The boundary for this would be x equals 4. So all along this, whoops, not that line, this line right here is where x equals 4. This one, since it's a less than, my points are not going to be in the solution on that line, so I'm going to do a dashed line. And since it says x is less than, I'm going to color in or shade all the points where x is less than. Okay, over here, my boundary is y equals negative 2. So down here is where y equals negative 2, and it's going to be solid because of my greater than or equal to. So solid line. And then it's y is greater than, so it's going to be the greater than portion of the graph where y is bigger than negative 2. Okay, so that is graphing linear inequalities. Please write down any questions that you have, and we'll talk about them in class.